by searching for divine meaning in numbers, 12th century scholars had stumbled across elements of the code.
It's very difficult to see a pattern.
Mysterious numbers and patterns that seem to be written into our biology.
Its only defense is a safety in numbers.
And as we've looked closer, we haven't simply found more numbers. We've begun to uncover their strangest properties and started to see deep connections between them.
Back in the distant past, in Neolithic times, around 4,000 years ago, an ancient people brought these stones here and arranged them like this. This is Sunken Kirk Stone Circle in Cumbria, and it's one of around 1,000 such structures that our ancient ancestors built across the UK.
Stretching back into the mists of time, the circle has been steeped in mysticism.
But whether the people who built this structure knew it or not, there is deep significance hidden inside this circle. Okay, so I need to start by measuring the diameter of my circle. So that's from one edge to the other. I need to go roughly through the centre. Whoa. So that's 27 and 90. Right. So now I'm going to measure the circumference of the circle. So off we go. So around the outside. God, got so much exercise doing maths before. And that's the circumference. So I've got 91 metres and 70 centimetres. What I'm going to do is to do a little calculation. I'm going to divide the circumference of the circle by the diameter. So 917 divided by 279. So that's roughly 3. A bit of mental arithmetic, not a mathematician's strongest point. Okay, 2 lots of 279. So, not far out from what I was hoping for. So when I do that, I get roughly 3.2 as the answer.
My measurements weren't very precise, but my answer is close to a mysterious number hidden within every circle.
So, for example, let's take this circular plate here. Now, I'm going to measure its diameter, 26.4 centimetres. Now, its circumference, it's a bit trickier, 82.9 centimetres. Divide the circumference by the diameter, I get 3.14. Now, let's take another circle. Measure its diameter, 12.8 centimetres. So the circumference is 40.2 centimetres. Divide the circumference by the diameter, and I get 3.14. In fact, whatever circle I take, divide the circumference by the diameter, and you're going to get a number which starts 3.14. This is a number we call pi.
No matter where the circles are, no matter how big or small, they will always contain pi.
It's this universality of the number pi which tells you that you've identified a piece of true code. In fact, if you get another number, it means that you haven't got a circle. In some sense, pi is the essence of circleness, distilled into the language of the code.
And because circles and curves crop up again and again in nature, pi can be found all around us. It's in the gentle curve of a river, the sweep of a coastline, and the the shifting patterns of the desert sands. Pi seems written into the structures and processes of our planet. But strangely, pi also appears in places that seem to have nothing to do with circles.
I started fishing in Brighton in 1972. I'm a fisherman, 40 years, catching Dover sole. That's the main target species for the English Channel.
How many fish do you think you get a day?
300 some days, 150
Right,
other days.
okay.
So say 200 would be average.
And you got me some Dover sole today,
Yes.
so I can have a way of what you've
Oh,
got
yes,
today.
you can play with them.
Okay. Okay.
What's remarkable is that with just a small amount of information,
It's 180 grams.
and by weighing a few fish,
Wow, that's a whopper.
I can use the code to tell me things about not just today's catch,
360 grams, 50 grams, 110 grams.
but about all the Dover sole Sam's ever fished.
Whoop, jeez, I'm back. I can even get an estimate for the largest sole that Sam is likely to have caught during his career. Right. So first of all, I need to work out what the average weight of a fish is, or the mean. So it's like 140 plus 190 plus 150. So now I need to work out the standard deviation. So that's 140. Let's square that. Bear with me, all right? Okay, almost there. So he said he fished for 40 years and 8 weeks during the year, 6 days out of the week, and 200 sole each day. So that gives you a total of 384,000 fish. Now, using these numbers, I can calculate that the largest one out of those 384,000 fish should be about 1.3 kilograms, which is roughly 3 pounds. So what's the largest Dover sole that you've caught in your career?
We call them doormats, the large ones, and you maybe get 4 or 5 a season. The largest, I'd say, was 3 to 3.5 pounds. An average Dover sole is that sort of size, and these.
Wow, that's huge.
It's a whopper.
Yeah.
It's always nice to catch big stuff, you know. Well, I think it is anyway.
Using the code, it's possible to estimate the size of the biggest fish Sam's ever caught, despite not weighing a single fish anywhere near that size.
Now, the reason this calculation is possible is because the distribution of the weights of fish, in fact, the distribution of lots of things like the height of people in the UK or IQ, is given by this formula.
This is the normal distribution equation, one of the most important bits of mathematics for understanding variation in the natural world.
The most remarkable thing about this formula isn't so much what it does, as this term here, pi. It seems totally bizarre that a bit of the code that has something to do with the geometry of a circle can help you to calculate the weight of fish. Pi shouldn't have anything to do with fish, yet there it is.
Just as the circle appears everywhere in nature, so pi crops up again and again in the mathematical world. It's an astonishing example of the interconnectedness of the code. A glimpse into a world where numbers don't just have strange connections, they have deeply puzzling properties of their own. Pi is what's known as an irrational number. Written as a decimal, it has an infinite number of digits arranged in a sequence that never repeats. And it's thought that any number you can possibly imagine will appear in pi somewhere. From my birthday to the answer to life, the universe, and everything. Because they go on forever, we can never know all the digits that make up pi. But luckily, we only need the first 39 to calculate the circumference of a circle the size of the entire observable universe, accurate to the radius of a single hydrogen atom. But as strange as pi is, it does at least describe a physical object. Some numbers don't make any sense in the real world, despite the fact we use them all the time. Numbers like negative numbers.
It's impossible to trade anything, stocks, shares, currency, even fish, without negative numbers. Most of us are comfortable with them. Even though we may not like it, we understand what it means to have a negative bank balance. But when you start to think about it, there's something deeply strange about negative numbers, because they don't seem to correspond to anything real at all.
The deeper we look into the code, the more bizarre it becomes.
It's easy to imagine one fish, or two fish, or no fish at all. It's much harder to imagine what -1 fish looks like. Negative numbers are so odd that if I have -1 fish and you give me a fish, then all you can be certain of is that I've got no fish at all.
Numbers can exist.
Safety in numbers.
And as we've looked closer, we haven't simply found more numbers. We've begun to uncover their strangest properties and started to see deep connections between them.
Back in the distant past, in Neolithic times, around 4,000 years ago, an ancient people brought these stones here and arranged them like this. This is Sunken Kirk Stone Circle in Cumbria, and it's one of around 1,000 such structures that our ancient ancestors built across the UK.
Stretching back into the mists of time, the circle has been steeped in mysticism.
But whether the people who built this structure knew it or not, there is deep significance hidden inside this circle. Okay, so I need to start by measuring the diameter of my circle. So that's from one edge to the other. I need to go roughly through the centre. Whoa. So that's 27 and 90. Right.
By searching for divine meaning in numbers, 12th century scholars had stumbled across elements of the code.
It's very difficult to see a pattern.
Mysterious numbers and patterns that seem to be written into our biology.
Its only defense is a